I'm Coach Pete of Math Coach Me. I provide math coaching and tutoring services, and I also provide free lessons at my mathcoach.me site. This is the third lesson in my trig series on thinking in radians. Unique to my approach is the use of Desmos calculators like this one to relay concepts visually, and trigonometry is certainly a visual topic, so well supported by the use of Desmos there. Also unique to my approach is there is a online version of this lesson where you can interact with these calculators. So you can take control, you can ask and answer your own questions like what is the conversion of 180 degrees to radians? And here we see it here, 3.14. You may recognize that as pi. There's a table here to look that up as well. So let's get started with this lesson on thinking in radians. You'll find a link for this lesson in the video description, or you can go to the mathcoach.me site and then go to lessons, and then locate this trigonometry 3 lesson, thinking in radians. So what are radians? Well, radians are just an alternate way of measuring the angles in a triangle or in a circle. And, we're very familiar with degrees. We know there's 360 degrees all the way around the circle. Degrees are part of our language. We're going to do a 360-degree analysis on that. We're going to look at it from all angles. Wow, that guy really did a 180 from his previous position. So it's part of our language. We're really familiar with degrees. On the other hand, not so much with radians. So although it's very useful in mathematics to express things in radians, it takes a little bit to get used to them. So that's what we're going to explore in this lesson. So first off, with a definition of radians. So as the measure of an angle when expressed in radians. So we have an angle here, theta. This is its starting arm, and this is the terminal arm for that angle. So the size of the angle, would be expressed in degrees as, that looks like about 60 degrees. Expressed in radians, it is the measure of the arc length. So this length going around the arc, from its starting position to its terminal arm, divided by its radius. And we see it here. So the arc length of the measure of that angle, the arc of that angle, divided by the radius of the circle, and that is expressed in radians. So 1 radian, going a little further down here, 1 radian is where the arc length for the angle is equal to the radius. So when we plug that into our formula, where the angle is measured in radians, so it's the arc length divided by the radius, but our arc length is equal to the radius, so it's radius divided by radius, which is 1 radian. Okay, before we begin our discussion on radians, we need to talk about pi and review pi for a moment. So pi is a number. It's also the 16th letter of the Greek alphabet, but we know it as a number, a constant number. Pi is approximately equal to 3.14, and that's how it's most commonly expressed in a simple form. However, here's pi to 20 decimal places, 3.141592, and so on, right? Pi is an irrational number. This never stops. It goes on and on and on. There is no repeating number pattern within this. So that's how it's commonly referred to, but just know that, it just goes on and on and on. Why would we ever use it? Well, it just naturally occurs in things. So let's take a look at how many radians there are in a full circle. So this is a formula that you're familiar with. The circumference of a circle is equal to 2 times pi times the radius of the circle. And if we apply that to our measure of angles in radians, so the measure of angles in radians is the arc length of that angle from its starting position to its terminal arm, so the measure of that arc length divided by the radius. Well, in a full circle, the measure of the arc length once around the circle is the complete circumference of the circle. So we can plug that in for the arc length, for a complete, for 360 degrees, one complete revolution around the circle, measured in radians, it is the circumference 2 pi r divided by r. So you can cancel those r's and you get 2 pi radians once around the circle. Let's explore that in a Desmos calculator. Okay, in this Desmos calculator, I have a unit circle, which is shown here, and I can control the size of the angle just by dragging this slider. So halfway around the circle, I'm at 180 degrees. And we know that if we go all the way around the circle, we get to 360 degrees when expressed in degrees. So what is that in radians? Well, I also have another circle here with a radius of 0.5, and I can control that with this slider here. I'm going to change the color of this. Okay, so this blue circle here, currently it has a radius of 0.5, but I can increase the radius, I can decrease the radius. So when the radius is, let me set it to 2, when the radius is set to 2, how many radians are there in one full revolution? Well, we know the formula to determine the number of radians in an angle is the arc length of the angle divided by the radius. And for a circle, and for one revolution around the circle, or 360 degrees around the circle, that arc length is equal to the circumference. And we know the formula for the circumference is 2 times pi times r. And when we divide that by r to get the size of our angle in radians, well, the r's cancel. In this case, it would be 2 over 2. That cancels. And we get 2 pi. And that's what we see here. This is the numerical representation of 2 pi, 6.28, and it goes on and on and on, just like pi does. And we can see that that's the same as 2 pi, right? So regardless of the size of our radius, regardless of how small or how big it is, this never changes, okay? So once around a circle, 360 degrees, or 2 pi radians. When converting from degrees to radians, we know there are 360 degrees in one revolution in a circle, or 2 pi radians. So the key relationship to switch between degrees and radians is 180 degrees is equal to pi radians. And if we divide both sides of this by 180, we get 1 degree is equal to pi over 180 radians. So when you're converting from degrees to radians, simply multiply by pi over 180. If you're going in the other direction, going from radians to degrees, you simply flip that conversion ratio, and to convert from radians to degrees, multiply by 180 over pi. Let's explore that in a couple of Desmos calculators. This Desmos calculator is set up to convert from degrees to radians, and if I look at the settings here, I can see that I'm using a radial grid versus just a grid, and my measure for angles is in degrees. And I can see that here, 30 degrees, 60, 90, and so on. So what we have here is a theta 1 angle. I can control the size of theta 1, and it is in degrees, and I can control its size using this slider here. Theta 2 is equal to theta 1, so in this case 30 degrees, times pi over 180. And we get the radian version of that, 0.5235, and so on. And if I look that up in this table, that is pi over 6. Or if I did the math, 30 times pi over 180 reduces to pi over 6. And I can do that for different size angles. So for 90 degrees, it's 1.57. Look that up in the table, that's pi over 2, or simply do the math. 90 times pi divided by 180 is pi over 2. So we can do that for all of these degrees when we're converting from degrees to radians. This second Desmos calculator is set up to convert from radians to degrees. And when I look at these settings, again, I'm using the radial grid setting or radial grid setup and radians as my measure for my angles. And I can see that here. So this is pi over 6, pi over 3, pi over 2 at 90 degrees, pi at 180 degrees, and once around the circle, 2 pi at 360 degrees. Theta 1 is measured in radians, and when it's at pi over 6, that is actually, if you divided pi, 3.14 la da da da, divided by 6, you'd get 0.523 and so on. And theta 2 is a conversion of that to degrees, so theta 2 is equal to theta 1 multiplied by 180 divided by pi. And for pi over 6, that would reduce to 30 degrees for theta 2. Now, we can move this around. We can check out pi over 3, which is 60 degrees, and pi over 2, that looks like 90 degrees, it's 90 degrees, and so on. So if you were to go to the lesson, you could interact with this directly, and you could watch this as many times as you want, and spend hours watching me do it. But I mean, if you do it for 5 minutes, particularly on this one, where we have the radians marked right there, and an instant conversion to degrees without having to go through a table, right? That's where you'll really learn. So interact. I encourage you to go to the mathcoach.me site, interact with this particular calculator in the lesson. This is the one to work with, right? Here's the one where you learn to really think in radians. So I'm going to fool around with a couple of numbers here. I know that pi is equal to 3.14. So when I put that in, that's converted to 179.908 la-di-da degrees. So about 180 degrees. That's not exactly pi. That's what we get. If I put in double that, 6.28, or the simplification of 2 pi, we get 300 and approximately 360 degrees, 359 point la-di-da, right? So here's an interesting one. I'm going to put in 1 radian. So 1 radian, okay, 1 radian. Remember the definition of 1 radian. So the unit radian is where the arc length is exactly equal to the length of the arc from the starting arm to the terminal arm of an angle. That length of that arc is exactly equal to the radius. That is 1 radian. So 1 radian is about 57.29, 57.3 degrees. So that's interesting and useful. It's about, it looks like it's about 60 degrees. It looks like it's, 1/3 of halfway around the circle, the 180 degrees. So just a useful thing for me, certainly, just to do that conversion. When I'm working on a problem and you get an answer in a radian format, in a numeric format that, I don't know, maybe 3.2, okay? And the angle that you're working with visually, looks like it's a little bit over 180 degrees, then that answer makes sense, okay? So being able to do that conversion, being able to understand what 1 radian is in degrees, it's a little less than 60 degrees, is very useful. Okay, there is a practice activity for this particular Desmos calculator. So you can use that calculator to convert all of these radians into degrees, and there's an answer key for that as well. Okay, that's it for this lesson on thinking in radians. Be sure to like this video. If you haven't already, subscribe to this Math Coach Me channel. And I'll see you in the next video. In the next video, we're going to explore special triangles and their trig ratios. So we're going to explore things like the 30-60-90 and the 45-45-90 special triangles. See you then.